Hello, and welcome to 5 Minute Math. Today, for our number talk, we are looking at these two mixed numbers and approximating the difference, trying to figure out if it's going to be less than 6 or greater than 6. So, hopefully, we are looking at our whole numbers and thinking, well, if I just wanted to look at the whole numbers, I'm going to get 9 minus 3. So, 9 minus 3 is going to be 6, which is right in between the less than 6 and the greater than 6. So really, I need to evaluate these fractions. And if the 2/12 happens to be smaller and the 4/40 happens to be larger, well, when you subtract a larger fraction from a smaller fraction, right, you can't do that without regrouping. It's just like trying to subtract a 9 from a 6. You have to end up regrouping. And so that's going to end up making it less than 6 because I'd have to regroup that 9 into an 8. But if it's the opposite, if that happens to be larger and that happens to be smaller, well, there's going to be a little bit left over. And so it's going to be a little bit greater than 6. So it really just depends on the 2/12 and the 4/40. And hopefully, your eyes are saying, you know what, you can simplify those fractions because at a certain point, we always need to evaluate every fraction we ever look at. Can you simplify it? Can you reduce it? Yeah, let's look at both of these. So 2/12, they're both even. So let's generate an equivalent fraction by dividing numerator, denominator by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. All right, so 2/12 is really 1/6. Let's do the same thing with 4/40. I could go by 2, but you know what? I'm going to go by 4s. That's going to get me where I want to go a little bit quicker. 4 divided by 4 makes 1. 40 divided by 4 makes 10. So I've got, take a look, I've got two unit fractions. I've got 1/6 and I've got 1/10. And I can compare these fractions without doing any type of common denominator. I could change these to 30ths if I really wanted to, but they both have the same numerator. So watch what happens. I'll draw you a few examples. So if I take a fraction, cut it into two parts, and shade one, that's the size I'm going to get. If I take that same square and I cut it into four pieces, shade one, look what I'm getting, smaller piece. If I take that same square, cut it into 8 pieces, and then shade one, look how tiny my pieces are getting. As my numerator stays the same, I can evaluate the size of the piece based on just looking at the denominator. And take a look, my 2 pieces are pretty big, but my 8 pieces are tiny. So imagine if I were to take it and cut it into 40 pieces or 12 pieces, right? That's going to be smaller and smaller and smaller. So I know based on this pattern here that this 1/6 is going to be greater than the 1/10 because taking a square and cutting it into 6 pieces is going to give me slightly larger pieces than if I took that square and cut the exact same size square into 10 smaller pieces. The more pieces you cut a square into, the smaller each individual piece is going to be. So 1/6 is greater than 1/10, which means 2/12, right? These are equivalent fractions, is going to be greater than the 4/40, which means I'm going to have a little bit left over. And so my difference is going to be a little bit greater than 6.